We've got a few more diagrams to post now. Now remember, the best way to learn is by doing it. It's called experience. You need to gain more experience reading diagrams. So don't shortchange yourself with that experience by watching this video first. Go to the link, print it out, color code it yourself, and then watch the video. Then you can experience it for yourself. Of course, there's many air conditioning electrical diagrams, but let's look at this particular one to see how it works. Every diagram has its purpose, and the purpose of this diagram is to show us how the air conditioning compressor clutch is going to engage so that the compressor can run. We always want to identify our components. We have the AC compressor clutch. We have the AC compressor clutch relay. Now notice this is a solid box, and it is located inside a dotted box. That dotted box then is the junction blocks under the hood. We also have our HVAC control module. We have our AC high pressure switch. Now notice that this pressure switch is closed, so it is normally closed. Anything that comes to it will pass through it because the switch is closed. And we have the PCM, which is going to do the control. We also have the AC low pressure switch. Notice that this switch is also closed at rest, so that anything that comes to it will pass through it. We have our AC high pressure recirculation switch. Now this switch is open, so at rest it is open as opposed to these which were closed. So things coming to this switch will stop because it is an open. We're going to talk more about this at the end of the diagram. And then there's another part of that junction blocks under hood up here. Now we need to find our power. The first one is hot at all times, and the second one is hot in the run and start position. Now we also have three powers down inside the PCM. How does this power travel? Well, the first one is hot at all times, so it's going to come down and stop at an open. The second one, which is switched power, comes down, passes through the coil, because the coil has continuity. It won't go through this resistor because it's going to change at that resistor, but it's going to pass on down and then it's going to stop at an open. Now let's talk about these three powers that are inside the ECM. Notice they're 12 volts, but on each one of these they're 12 volts and they immediately hit a resistor. Each one of them is a 12 volt supply that hits a resistor. So the 12 volts immediately meets a resistor, so it holds in waiting. In other words, that 12 volts is there because there's no load and there's no ground. It's just 12 volts. I'm going to explain this a little bit more in a moment. But first, let's find our grounds. We have the first ground. We have our second ground. And then there's also a ground inside the PCM, but this will be a switched ground. Now, how does this ground travel? Well, this one just travels up, goes through the coil because there's continuity, and it stops at an open. Now, the second one is the same ground, but it is spliced. It comes over, and it goes through this low-pressure switch, which was in the closed position. So this ground is going to travel through that switch and go to the PCM. Now, if you look at the PCM, we've got ground, and we've got power, and we've got a resistor in between. How does this work? Since the power has access to ground, that power can travel through this resistor. It's going to change and become the signal to the PCM that the AC low pressure switch has worked. Let's look at this just a little bit closer. So this resistor has 12 volts from the PCM at the top. It has ground at the bottom. So as that voltage travels down, it's going to be resisted down, and at some point it's then going to send a signal to the PCM. It's not going to be a 12 volt signal. It's going to be a voltage resisted down, and that's going to go to the PCM. The PCM is going to look for that signal. When it sees the correct resisted voltage, it'll know that that switch is now working. So here again we have our 12 volts supplied at the PCM. It's going to travel down through this resistor looking for ground. It'll find ground, but because it is 12 volts resisted down when it finds ground here, it's going to send a very low voltage to the PCM, and that's going to tell the PCM that the AC low pressure switch is working and is closed. Now our next ground is over here, and it's going to travel up and stop at an open. So now let's see how this circuit works. The driver wants air conditioning, so he pushes the button on the dash. The HVAC module then is going to send a ground signal through this closed switch to the PCM. We've got the same thing here, 12 volts with a resisted voltage going to find ground. So this now is going to be a signal inside the PCM that the AC has been requested. Now how do we know that this HVAC module sent ground? It doesn't say it up here, but if you know the diagram and how it works, the diagram shows that we've got 12 volts. 12 volts needs ground. This switch is closed, so the ground has to be coming from here. If this were to send power, you'd have power meeting power, and that wouldn't work. You have to have power here and a ground here, and then you'll get your signal. So let's see now how this PCM handles all this and what it actually does. The PCM receives the AC request, and then it verifies that the low pressure signal is within range, in a resisted range, and that the high pressure signal, again, is a resisted value and it's within range. So, if all of those circumstances are matched up to the logic inside the software of the PCM's next step is to then close the relay switch, which is again internal inside the PCM. So this switch is going to close, ground is going to travel up to the load. This is going to energize, become an electromagnet, and close the relay. The relay, once the relay closes, power is going to find ground, become switched power and find ground. The AC clutch is going to engage, and the compressor will run. Now, of course, electricity is so fast, all of that happens in a split second. I've just slowed it down so that we can see the mechanics of it. Now, what's all this about on the right side of the circuit? We've got an AC high pressure recirculation switch. High pressure. So, if pressure builds to above approximately 350 psi, this switch, which is now open, is going to be closed by pressure. The switch will close. Now you're going to have switched ground travel up into the PCM. Now we've got the same type of circuit here. There's already 12 volts there holding and waiting. It's going to go down through this resistor to find its ground, and then it's going to send a signal to the PCM that the AC system has high pressure. Now we know that high pressure in an AC system is not good. It wants to try and keep that pressure low. So what it's going to do is close the recirculation door in your heating and air conditioning system, so it's going to let the cooler air that's in your cab pass through the evaporator instead of the vent air from the outside, and that's hopefully going to lower the evaporator temperature because cooler air is being able to pass through it. You'll see this circuit when you have automatic temperature control, because the PCM then can open and close the recirculation door as it sees pressure building. So it's just like if you were to manually push the recirculation door because you wanted to have the air from the cab go through the air conditioner instead of just the outside air. And then it's going to use an actuator motor to close the door on the recirculation. Now, if pressure would continue to build to over 450 or so psi, that pressure then is going to open this high pressure switch. So when pressure opens this switch, we lose our AC request signal. It's just like you turn the air conditioning off, because the PCM no longer sees the AC request signal. So the compressor will stop running. So this part of the circuit is to help keep the evaporator temperature down, and this part of the circuit is if pressure gets too high, it will open the circuit and turn the compressor off.